Okay, welcome back to section 9.4. We've got a second example. This time it's a work rate problem. I know that's everybody's favorite. But let's talk about this one. We're told an old pump requires 6 hours longer to empty a pool than does a new pump. With both pumps working, we know that the pool can be emptied in 4 hours. We're asked to find the time required for the new pump working alone to empty the pool. So what we're going to do right here is we're going to start by naming a variable right here, and we're asked to find the time of the new pump working alone. So let's let that be our variable. Let t be the amount of time required for the new pump to empty the pool all by itself. Right? If we're given that, then, well, what would be the time required for the old pump? We're told that the old pump would take 6 hours longer. So however many hours long the new pump takes, if it takes 3 hours, then it would take the old pump 6 more hours, 9 hours to deal with that, right? So whatever t is, we add 6 to that, and that's going to be the rate of our old pump. That's going to be our time, required to empty the pool. Okay, remember that if we're looking for a work rate, it's 1 over the time required. So for the new pump, the rate required is 1 over t. For the old pump, the rate required would be 1 over t plus 6. Now again, all we really need to do is organize this into our required information, and we remember that whenever we had one of these problems, we set up a little table to kind of help us organize this, and that required that we were able to put in the rate for each item working together, the time working together, and the part of the task completed by each part within the system right here. So we've got 2 pumps right now. So let's talk about our new pump and our old pump. The rate for the new pump is 1 over t. So 1 over t of the pool emptied per hour. The old pump would be 1 over t plus 6 of the pool emptied per hour. But now we look at the time of them working together, and we're told that working together, the pool is emptied in a total of 4 hours. So that's the time we're going to put in this column right here. We're saying that the rate of the new pump emptying the pool, for the amount of work that it does in 4 hours, it's going to be 4 over t of the pool drained. We look at this old pump right here. Its rate is 1 over t plus 6, so 1 over t plus 6 of the pool per hour times 4 hours gives us 4 over t plus 6 as the part of the task to complete right here. So now we're in a position that we can set up our equation, and it turns out to be a rational equation. 4 over t plus 4 over t plus 6 will equal 1 whole pool being emptied. Well, there we go. This is the equation that we need to solve. In a rational equation like this, that means that we have to multiply through by our LCD. And the least common denominator in this case is the quantity t times t plus 6. And we're going to do that to clear the fraction. So I'm going to multiply both sides by t times t plus 6, and I'll write it as t times t plus 6 over 1 times each quantity just to show what's going to cancel right here, plus t times t plus 6, again over 1, times 4 over t plus 6. And that's going to be set equal to 1 times t plus 6. All right, let's see what's going to happen right here. In the first case, when we multiply by 4 over t, t cancels. So we're left with 4 times the quantity t plus 6 in our first term on the left. In our second term, t plus 6 cancels with the denominator here in 4 over t plus 6. So we're left with 4t on the left. And on the right-hand side, if I distribute, I'm going to get t squared plus 6t. So let's see what we can do right here. We distribute 4t plus 6 times 4, 24, plus 4t is equal to t squared plus 6. And in order to solve a quadratic equation, we have to set this thing equal to 0. So I'm going to simplify one more time on my left-hand side to get 24 plus 8t equal to t squared plus 6t. And setting this equation equal to 0, I'm going to subtract 8t from both sides. And I'm going to add, or we're going to subtract 24 from both sides. So we should get a new equation that looks like this. T squared minus 2t, 6 minus 8 is negative 2, minus 24 is equal to 0. This one can be done by factoring directly. In this case, let's go ahead and factor t. We need two factors of negative 24 whose sum is negative 2. That would be negative 6 and positive 4 in our factors. And so we're going to set each factor equal to 0. T minus 6 is equal to 0. T plus 4 is equal to 0. And we get two solutions. T is equal to 6, or t is equal to negative 4. Now we go back up to the context of the problem. It says, find the time required for the new pump working alone to empty the pool. Well, we can't use a negative answer. There is no negative time. So in our case, this turns out to be an extraneous solution. But if we look at the first answer, t equals 6, that would work. We could say that it takes 6 hours for the new pump working alone to empty the pool. And that's our answer that we wanted. So we're done. Okay, one more example to come in the next video.